Alright, welcome to today's video. We are going to be looking at boiling point and melting point of substances. Remember that these boiling point and melting point are their physical properties that we use to determine if a substance is pure or not. From our previous video, when I talked about pure substance and impure substance, I told you that pure substance, they have a sharp and a fixed melting and boiling point. But impure substances do not have a sharp boiling and melting point, because the introduction of that impurity either lowers or increases the boiling and the melting point. So today we are going to focus on just boiling point and melting point and how we can use it to determine the purity of a substance. Now, before we go into that, you must know the definition of these two things, because in your exams, in JAMB exam, they can ask you, dash is this, dash is defined as. So you should be able to understand the difference between boiling point and melting point with respect to what? Definition first. So today, the first thing we'll talk about is melting point. Melting point. Okay? So what is melting point? What is melting point? When something has melted, when you say something has melted, picture it in your eye. Picture an ice. An ice, which is water in solid state, right? When it melts to liquid, that's melting, right? So now let's picture this thing now in the definition and see if it's going to make sense. Okay? So the melting point is the temperature at which a substance transitions from a solid to what? A liquid state. So that makes sense that when you have an ice, which is water in solid state, transitioning or changing from the solid state to the liquid state, we say that that substance has melted. Does that make sense? Yes. Now, what this thing actually means is that they, at that point of melting, the solid and the liquid state, they have what we call, they are in equilibrium state. Okay? So solid and liquid phase are in equilibrium. That is the point when melting is said to have taken place. So they can ask you, at equilibrium in melting point, what is equal to this? At equilibrium, the solid and the liquid state are at that same point. They are at that same time, they are equal. They are in equilibrium. And at that point, we say that what? Melting has taken place. Now, most students might not be able to differentiate between melting and boiling point. So now let's talk about boiling point, so I can be able to understand the difference between these two. Now, what is said to be called boiling point, or what is the boiling point of a material, or what can be defined as boiling point? Now, the boiling point of a substance is that temperature at which the liquid vapor pressure equals the atmospheric or the pressure within the environment. Okay, I repeat. The boiling point of a substance is the temperature at which the liquid vapor the liquid vapor pressure equals the pressure around it, or you can say atmospheric pressure. Because what is around us is an atmospheric pressure. So when the vapor pressure of that liquid is at equilibrium with the atmospheric pressure, then the liquid will start to boil. So in JAMB, most of the times in JAMB, they will always say, dash is the temperature at which the vapor pressure equals the atmospheric pressure. The answer to that question is what? Boiling point. Take note, the vapor pressure of the liquid must be equal to the atmospheric pressure for a liquid to what? Boil. So what this actually means is that at this temperature, now remember that if that substance is boiling, let me give you an example. For example, let's say we have that same water that has melted from the solid to the liquid state. Let's assume that we keep heating that substance. The liquid will start turning to what? Water vapor. That's when you're boiling your water, you see that the water begins to evaporate, right? Now, we are saying that as that water is evaporating, at that point, the temperature at that point is now constant. So if you keep on increasing that temperature, the temperature is not changing. You are just converting the liquid to what? To gaseous state. The temperature remains what? Constant. The temperature at the boiling point is constant. Look at this statement here. At this temperature, that is the temperature of boiling point, adding heat, that is increasing the heat, causes the liquid to turn into vapor, but it doesn't raise the temperature. That is, the temperature is what? Constant. So take note, at boiling point, temperature remains what? Constant. If you like, increase the heat, keep on increasing the heat, that is increasing the heat of the reaction, the temperature remains what? Fixed. So now, From these two definitions I gave you, you should be able to spot out the difference between melting point and boiling point. You should be able to know that boiling point deals with what? Liquid transitioning to what? To gas. But melting point deals with what? With solid transitioning to what? To liquid. They are two different things altogether. Now, the main thing you have to focus in these two things now is how can you relate these two things to the purity of a substance? Because we said that the purity of a substance depends on the melting and the boiling point. How can we relate it? How can we use it to classify whether a substance is pure or impure? Let's start with the melting point. Let's look at these few points. These few points you are seeing here summarizes all you need to know about the purity. What happens to the melting point of a pure and an impure? Does it increase? Does it decrease? We'll find out. Okay? Now look at this statement here. We say that what? Pure solids melt at a definite and sharp temperature. I have told you this from the previous video. In our previous video, when I talked about pure substance and impure substance, I was able to tell you that pure substance, for the fact that there is no impurity in them, their melting point and boiling point will be sharp. That is, it will not be broad, because it is just one thing that is present. There is no impurity present, so everything is homogeneous, so they can easily just have a sharp melting point. There is nothing that is in the substance that will alter the boiling point or melting point as a result of maybe that thing having a different melting point with what is already existing there. For example, if I have, let's say I have an element, sodium, for example. If I have a sodium element and only sodium is inside that substance, the melting point will be fixed and sharp because it is just sodium. But if I have a sodium that contains impurity that is there, those impurities can either lower the boiling point or melting point or increase it. So take note, pure substances have a sharp and a fixed melting point. Of course, impure will not have that kind of thing. It will have a broad, it will vary. Okay? Now look at this point here. Impure solids that melt over a range of temperature usually lower the true melting point. I repeat again. Impure solids melt over a range of temperature usually lower than the true melting point. This makes sense, right? So the presence of an impurity causes the melting point to what? To be lowered. Lower than the actual melting point of that substance. So if you introduce an impurity to a substance, it's going to what? Lower the melting point as a result of what? The introduction of what? The impurity is present. Again, so look at the summary of what I'm trying to say here. The summary is this. The greater the impurity, the broader and the lower the melting point. This is a JAMB question. Take note. This thing comes out in JAMB. Know this point very well. This is a summary of the class. The greater the impurity, the more the impurity, the broader or the lower the melting point. So what it means is that impurity lowers melting point. Take note of that. It does not increase it though. Impurity lowers the melting point. Now, let us come to boiling point. How does boiling point determine the purity of a substance? A pure liquid boils at a fixed temperature. This one makes sense to you, right? Remember what I told you. For this also, this and this statement, I talked about it in the previous video. I talked about it. These two statements are the same. They are the same. I said that an impure solids melt over a range. Sorry, I'm talking about not this. Sorry, this statement here and this statement here, they are the same. Okay, so a pure liquid boils at a fixed. They have a sharp temperature or a fixed temperature under a given pressure. Okay, the difference between this one is that this one is talking about a definite and a sharp temperature. This one is talking about a fixed temperature. Okay, so now, but they are the same. Pure substances have a sharp or a fixed temperature, melting point, temperature at which it melts or at which it boils. Okay, so look at this. Look at this point. This one is important. Look at this point. An impure liquid boils over a range of temperature, often higher or lower than the boiling point of the pure. This one is different from this. You know why? Because it depends on the impurity that is present. It's not like this one that impurity lowers it. For this one, the impurity that is present will determine if it is going to be higher or lower than the pure one. I repeat, if you have an impurity in a substance, if you have a solution that is impure, and it boils over a particular temperature, that impurity that is in the impure will either lower or increase. So this one is not direct, it's not a direct question. They can't ask you this one because it depends on the impurity present. Look at the one they normally ask, melting point. But for this one, the impurity present can determine whether the boiling point will be lowered or increased. So it's a two-way thing. It's not just a one-way thing, unlike this one that is one way. So the end point is that these 2 points, melting and boiling point, they are used to determine the purity of a substance, because in the laboratory, when you do the practical aspect of this, from the laboratory, when you look at the measurement of these temperatures, once you see a sharp or a fixed, when I mean sharp means that the temperature difference will not be too broad. For example, let's say something boiled from 100 degrees C to 101 degrees C. This is a sharp. This is a sharp. It's not too, the gap, the range is not that long. But when you have something like, say, 100 degrees C to, let's say, 120 degrees C, you see that the gap, the range is very broad, it's very large. So once the range of the boiling point is large, then it means that there should be an impurity somewhere here. But once it is sharp, like this one, the first one, or somehow fixed, like this one, then we say that what? It is what? A pure substance. So pure substance have a fixed temperature or boiling point, while impure have a broad, their range. They have a range of, look at the range, 100 to 120. So the range there is almost 20 degrees C in terms of measuring the differences. So take note of these things. So at the end of this video, you should be able to understand that boiling and melting point are 2 different things, first of all, and we can use them to determine if a substance is pure or impure. Pay attention to this. Like I told you, this is the one you see mostly in your exams. Also, link it to definitions between these two. And if there's any question you want to ask, you can ask them in the comment section. So I believe at this point that this video on boiling and melting point has been cleared in terms of definition and in terms of differences, and also in terms of purity of a substance.